Section 3.3 Chebyshev rule and the empirical rule. What Chebyshev did, he found out that for any quantitative data, quantitative means numbers set, and any real number k greater than or equal to 1, so k must be greater than or equal to 1, he found that at least 1 minus 1 over k squared of the observations lie within k standard deviation from the mean. Means like either side of the mean or within the mean. That's what he found. So for example, if we take k equals 2, that's the smallest one. If k is 2, then substitute that into 1 minus 1 over k squared. That would be 1 minus 1 over 2 squared. 1 minus 1/4, that's 3/4. That's, if you multiply by 100% and simplify, that's 75%. So this means at least 75% of the observations in any data set will lie within two standard deviation from the mean. Two standard deviation from the mean. So this means it would be between x bar minus 2 standard deviation and x bar plus 2 standard deviation. If you take k equals 3, 1 minus 1 over 3 squared, that would give us about 88.8%, which is about 89% of the data will fall within 3 standard deviation from the mean. Okay, so that's what this means. That's what the Chebyshev rule says. And you can be asked for totally different kind of questions on Chebyshev. You could be asked about k equals 4, or 1.5. All you have to do, just substitute the k value in and see what the percentage would be. So if you're asked for 2.5, okay, because k is a real number, it doesn't have to be always an integer, it could be in decimal. And then I calculated it, I put 1 minus 1 over k squared, and that gave me about 84%. Okay, how they can ask it in a different way. Let's say they ask us, other example, if let's say the mean is 21 and the standard deviation is 5, at least 89% of the observations lie between two values, or between which two values. Okay, that's what the question. The first thing is 89%. 89%, if you look back up, the 89, it stands for 3 standard deviations from the mean. So we're gonna take x plus 3 times standard deviation. The mean was 21 plus 3 times 5. So you do 21 plus 15, and that gives us 36. And 3 standard deviation below the mean, 21 minus 3 times 5, 21 minus 15, which is 6. So the two values are going to be 6 and 36. So based on this mean and standard deviation values, at least 89% of the data set or observations will fall between 6 and 36. Another example. A data with size 60 has mean 15, standard deviation 3, at least between how many observations lie between 9 and 21. So here they give you the value, the kind of like two different values, and we need to know how many observations fall in there, how many of them. So the first thing we find is this is the mean. I'm gonna put it here. The mean is 15. It says 3 standard deviation. The standard deviation is 3. So if you add 3 to 15, that's 18. If you add another 3, that's 21. Oh, we reached 21. If you go down by 3, that's 12. Another down by 3 is 9. I see the 9. So that's the mean. And notice we are within 2 standard deviations. Within 2 standard deviations from the mean. So within 2 standard deviations, if you remember 2 standard deviations here, k equals 2, 2 standard deviation was 75%. So 70, we find 75% of the total number of observations given, 60. That will tell me how many will fall in between these 2 standard deviations, between 9 and 21. If I cancel the 0 by 5, 15, by 5, 2, by 2, 1, by 2, 3. 3 times 15 is 45. So 45 observations. 45 observations. Now the last thing here is called the empirical rule. The empirical rule is important in many cases. What the empirical rule says, approximately 68% of the data will fall within 1 standard deviation, 1 standard. 95% of data will fall within 2 standard deviations. And 99.7 that I mentioned in the previous section will fall within 3 standard deviations from the mean. So graphically, if you want to put it, we usually put it on a symmetrical graph like this, which is like a bell-shaped graph. Bell-shaped, symmetric. So you can see the mean is in the middle. If you go up 1 standard deviation, below by 1, 68% of the data will fall in there. If you go up 2 and down to 95 will fall within 2 standard deviation, and 99.7 will fall within 3 standard deviation. I usually like to add more details. If this is 68%, means 34% data will fall here and 34% will fall there. Then within 95% data, if you do 95 minus 68 and then divide by 2, will be 13% here, 13% there. And then the next one would be, if you do 99.7 minus 95 and divide by 2, that would give 2.35% and 2.35%. And 100 minus 99.7 and divide by 2, that will give us 0.15%. And the last one here, 0.15%. That's what the empirical rule says. That's what the empirical rule says. So here, like, they give us a data and then they plot it on the graph using a software and based on the frequency. So they plot it on the graph like this. Notice how it's almost a bell shape. You know, you can find from here, they found the mean. It's easy to find. And they went out by 1 standard deviation, 2 standard deviations, and 3 standard deviation, above and below the mean. And now if you want to plot all of this, given numbers, given data, you'll find possibly all the data falls within 2 to 3 standard deviation from the mean, like above and below the mean. That's what the empirical rule says. So always keep an eye. Sometimes they ask the question in a backwards wording as I did in the previous example. Sometimes they give you some data, or they give you the mean, and they say within how many standard deviations the numbers fall, 73.61 and 339.29. But they give you the mean and the standard deviation, which we call it S. And then what you need to do is just keep adding the standard deviation to this, to the mean, or add it again and see what you get, or you subtract it, x bar minus s, x bar minus 2s, da da da. So that's about this section.